So the London assets that we have at the moment are borough profiles that we basically took data from the London data store and also some data from Public Health England, and those were Excel files that were available by those two organizations, and we turned them into to a kind of Orion IoT-like data. We took traffic counts from Department of Transport, so there's one day in October where they stand on certain street corners and they count traffic, and we turned that also into kind of IoT sensor. We used for transport. We took the transport API and we looked at the service level of train stations, and then we hooked up to the London Air Quality Network for giving pollution.
Sorry. I think you have to go to slide 2. I'm seeing the first one.
You're seeing the first one. Let me see. This one.
Yeah. Okay.
This one.
Yeah.
And right. So yeah, we have the London Air Quality Network, and then we have also environmental sensors from Intel that they deployed in the Queen Elizabeth Olympic Park. So to give you a bit of detail of the different data sets. So for the London Borough profiles, so basically you get one sensor-ish object for each of the 33 London boroughs, and you will get measurements of population density in that borough, the carbon emissions, the amount of green space, the average house price, the average number of cars per household, the average household income, prevalence of obesity, and walking and cycling frequency. And a bit, if you look at
I still see the second slide. Sorry for the interruption. I don't know if it's only me that's seeing.
And okay, so
we just see your PowerPoint, so maybe just don't use your full screen mode.
Okay. Now you see. I'm on slide 4 with Jason. Where
now I can see the slide 4. But when you change your slide, just ask because.
Okay. So this is kind of a bit of cutting and pasting of the JSON result for one London borough, and we can see there we have the geometry of the borough. We actually have here a triangle representation of the borough, just for to make to kind of use less space. But in the actual API, you get the actual polygon for the geometry of the borough, and then you can also, in the location attribute, you'll get the centroid of that polygon. And then on the right, you can see 2 example attributes. One is population density, and you can see that that's measured in people per hectare. And you can see average house price, or house price, which is measured in pounds, as the monetary value in pounds. And then you get the rest of the attributes are in the same format. Moving on to the traffic counts. And now I change slides. Did you also change slides?
Yes.
Okay, so that probably works now. So as I said, this is yearly traffic counts done by Department of Transport, and basically what they count are bicycles, motorcycles, cars, buses, and then light good vehicles and heavy good vehicles. And they do this around just below 2,000 road segments inside London. And coming back to the JSON, it's very similar, except that the location is just a point, and here we can also see an attribute that is called the origin. It just basically says where the data came from, saying that this comes from the Department of Transport. And on the right, we can see, for example, for a certain location where it was counted, we can see that there were 320 buses on that day, and these 35,000 cars that went through that point. And if you want to see the actual methodology that they use for doing the accounts, you can go to the DFT website and look at the traffic counts data to see the actual methodology. We also looked at, we got data from Transport API, and what we did there is that we calculated a metric that we call train station performance, and that's basically you can get a list of the trains that are about to leave over the next. I don't remember the time span. I think it's an hour or so, hour or two, and you can see the percentage of train that is expected to be on time. So just to jump directly to an example, here we get Victoria Station in London, and we get the location, and we see that at this point in time there were 96% of trains that were on time. We connect to the London Air Quality Network that is managed by the King's College in London, and they have sensors that can measure concentration of nitrogen oxide, the sulfur dioxide, and also small particles, two types of small particles. And as with the other assets, it's starting to become familiar, I guess. You've got the location where the device is, and for example, for this nitrogen oxide, you can see that they measured as micrograms per cubic meter, and that was 46.2 at the last measurement. I see that we don't have time, which is probably a bug, but we should put that on the list to fix that, to have a time value here. Finally, the environmental sensors. So those are a number of sensors that are deployed in the Queen Elizabeth Olympic Park, and they measure temperature, rain levels, wind direction intensity, humidity, barometric pressure, and light intensity. And again, an example, usual thing with the location, with the type and location, and we can see here, for example, there is wind direction and wind speed. And another observation that actually now we probably should have a better data type here to measure, to say actually what this measure means, but we'll update that. And yeah, for more information, you can look at this very easily rememberable URL, or you can also find it on the main GitHub, which might probably be easier